We are headed toward the end of the semester by wrapping up some things with statistics and statistical displays. Let's see what happens in here. We are very close to being done. For this first screen, I'd just like you to list the things that you're concerned about for finishing the semester. Remember that I am here to help you out. If you want to pop by office hours or ask questions during class time, those are great ways to get things resolved. In this unit, we need to be able to create a 5-number summary. We were able to pull off all of the pieces from box and whisker plots in the last unit, but this time we'll want to be able to create those 5-number summaries. So to do that, we need to be able to find the minimum of the data set and its partner, the maximum. And then we also need to be able to find the median. And those three things we did in the last unit for sure. Finding the lower quartile, or Q1, or the first quartile, or the 25th percentile, those are all the same meaning. This will be the median of the lower half of the data set. And then by symmetry, the upper quartile, or the third quartile, or the 75th percentile is the median of the upper half of the data set. And we'll practice finding all of these features on an example data set next. So here's our data set, and I just copied it into the box. I think there are 9 entries here. They are already organized for us from least to greatest, but if they were all mixed up, you'd want to organize them first. I pulled off the minimum and the maximum already. The minimum value is 10, the maximum value is 42. There aren't any units on this example set, but usually there would be, like dollars or grams or ounces, something like that. The median is 18. If I highlight this one, you'll notice that there are 4 data points below the median and 4 data points above the median. So 18 is the exact middle of the data set. To find these quartiles, Q1 and Q3, Q1 is the median of the lower half of the data. So if 18 was our median, let's look at all of the data points underneath that. So all the way there, 10, 12, 15, and 16. We want the median of just those. To do that, 12 and 15 are in the middle, and so we'll need to find the average of those two. So 12 plus 15, and then divide by 2. And that will give us 13.5. For the third quartile, remember the median is 18. For this upper quartile, we look at all of the data points that are above the median. 30 and 40 are in the middle of that data set, so we need to find the average of those two. And that should be 35. So now we have our 5-number summary. We have the minimum and the maximum. We have Q1 and the median and Q3. On the very last portfolio assignment that you need to do, your job is to do some research, come up with 10 data points within a single context. So sometimes students use things like the weight of, last semester someone used the weight of grapes. They had a kitchen scale and they measured 10 grapes for what each one of them weighed, and they recorded that and recorded themselves making those measurements. I've had students use outputs from their wearable fitness gear, so Fitbit data. Anyway, they take 10 of those data points, find a 5-number summary, and then be able to interpret the summary in terms of quartiles and percentiles. We're going to get to percentiles in just a second. We'll also need to be able to find the mean, median, and mode of the data set, and I'm just kind of wondering how you're feeling about doing this at this point. If you need help, let me know. So here we are interpreting percentiles. That's where we're going next. I give an example. If we know that someone's salary is at the 70th percentile for their job description nationwide, that means that 70% of people with the same job description will have the same salary level or lower. Same salary or less, it's a marker. This would chop off 70% at that same level or underneath. And that leaves 30% of the people to be above that level. But I think if you stick with just this description where we talk about at the same level or below, I think that's a very safe way to interpret percentiles. We'd like to be able to do this with other percentages, so let's give it a try. I give you these two. We have the third grader's weight at the 29th percentile. I think I just copied that down here. I did. If a third grader's weight is at the 29th percentile, that means 29% of third graders have the same weight or less. Or I guess you could have said same weight or below. If a student's test score is at the 90th percentile, that means that 90% of similar test takers had the same score or below. Or you could have said less. So whenever you have a percentile, you can transfer it into a percent format where we have comparing to similar things like similar third graders or similar students or test takers in this case at that same level or below. We've been working on measures of central tendency or measures of center, and those are mean, median, and mode. We also worked on range. That's a measure of dispersion or spread. We need to work on standard deviation. We need to get to this, and that's a little bit sticky, but you're tough. I'm sure we can make that happen if we work on it together. It is more complex, but we'll give you kind of a format for finding that. And I just want to make sure before we move on to that, fancy notation for the mean. You'll see this in the course pack, this X bar. And those of you going on to any kind of a class on research, they're likely to talk about X bar for the mean or the average. So if you see that, I want you to think about, oh yeah, it's the mean or it's the average. So we'll need that in the next video.